The angle of elevation of the sun is 15 degrees. How long is the shadow of a 64-meter tall building? So the key here is to draw our diagram correctly. So I'm going to draw a nice building here. It doesn't really matter which place you put it in. So here's our building, and this building is 64 meters tall. Now it says here the angle of elevation of the sun is 15 degrees. So visualize the sun starting at 0 degrees, sunrise, beautiful sunrise, and then it's going to be here at 15 degrees. There's the happy sun, and we're just going to draw a line here. So from here to here, and here to here approximately, there's a nice line. And the key here idea is that when the sun is at 15 degrees, we need to write 15 over here. Because the sun is rising, the angle of elevation is elevating. The idea of the angle of elevation is that it's going up. Imagine person's standing here, and the person's gonna tilt their head up to look at the sun. Hopefully they're wearing some nice sunglasses, but they're gonna look up. When we elevate our neck, we look upwards. However, if we were to have an angle of depression, we'd be bowing our head down and looking downwards. But right now, if the persons were to look at a sun, we need to elevate our chin and look upwards at the sun. So here's the sun. The sun is shining this way. It's beaming its light. It's very bright here. Bright, 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 bright. However, behind this building, there's going to be a shadow over here. This is all a shadow. It's darker. So the question is, how wide is this x value? This here is the length of the shadow. We'll call it x. How long is this? Now we have this is a right angle triangle. We can see here we have an angle, we have an opposite side, and so therefore we can use basic trig, SOHCAHTOA, to solve for this adjacent. We have SOHCAHTOA. Here's the angle, we have the opposite, and we're interested in the adjacent. Opposite, adjacent. So we're going to use the tangent ratio. Tan 15 degrees, don't use radians, use degrees, is equals to opposite over adjacent. Opposite is 64, over adjacent is x. So we can use some cross multiplication here. We have over 1, so x times tan 15 is x tan 15 equals 64. Divide both sides by tan 15, and these cancel out. We can solve for x, and so therefore x is equals to approximately, so this is in degree mode, 64 divided by tan 15 is approximately 238.85, and we're talking about meters. So the closest answer here is C. Now just a little tip here, whenever we have this unknown found in the denominator, a direct method to solve for x would be x is equals to the numerator, whatever's on top of the x, divided by the other side being tan 15. So we could use cross multiplication and then cancel out as we did here, or if you want to just, because we see this pattern so often, just one little quick tip is you can solve for x in the denominator. If you say x is equals to the numerator on top of that x divided by the other side.